hasn't made it. We met as faculty, most of us on the research team, about 2 weeks ago, and I've invited some people from outside the campus and other people on campus to join us. And so I thought it might still be useful to go back over some of the objectives and 4 things that we've set up to do. And I'll do this more quickly than we did in our research team meeting, but it'll help kind of ground us repeatedly in what our purpose is. We are going to be tape recording these so that they'll be available on a regular basis at a website as yet to be determined, but I'm looking for help in volunteering someone's server to host that. Set up a little shell website so we can have a place for this Teams, PowerPoints, and the videos of the workshops and so forth we can make available. We're also talking to some of our partners in Salt Lake about setting up a broadcast site down there so that people from Salt Lake can not have to drive 4 hours to attend an hour-and-a-half meeting. And I think that'll make it a lot easier to get a few other people plugged in as stakeholders. So let me just roll on this. I expect probably some people will still come in, but let's not wait. The grant is not a research grant. The grant is an NSF grant that was designed to build a research team. And the vision of the research team goes beyond the boundaries of the universities. Let's just start with that the point is to kind of get a team in place that's capable of doing work together. I just came back from a 3-day workshop on interdisciplinary research, and I'll be talking a little bit about some of the things that I learned there. But one of the bottom line principles of doing interdisciplinary research or trying to reach across boundaries is that you really have to know your partners, and you have to be able to learn how to speak one another's languages, and that's true across disciplines. It's true between different groups in society. And so we're going to probably, as one of our objectives, just get to know one another better and get to know how we do work in the different places that we all work. In the end, we'd like to write 1 or more proposals to get resources to do research, to do action, to do projects. That motivates people on campus to participate because we're all required to do that as part of our jobs, but it also gives us the resources to do the work that we've all dreamed of doing. And so we got 6 months before the deadline comes up for the program that funded our first phase, and we're looking at other programs and other opportunities that might not even be research-based, depending on who the partners are, that we ought to all keep in mind. So the degree we get team built, to the degree that we get a common vision as to what we'd kind of like to get done, we can go after resources to do that down the road. But I would like to give us a break this fall to not worry as much about that and worry more about understanding the core question. Now, the core question that we used to organize our proposal was the second bullet on here, and essentially what are the intended and unintended consequences of changing how we manage water in landscapes like Cache Valley. And we premised that by saying there are going to be changes. There's going to be water scarcity. There's going to be increasing demands for water. It doesn't take a rocket science to look at the trends and say we're getting to a place where we're going to have to, and people are going to, whether we decide to or not, change the way they manage water resources. And it has been my judgment in the last 4 or 5 years working on these topics that we don't know everything or even enough, I think, about what the decisions that get made mean in terms of the dynamics of this water system. And so if we want to make decisions that have the consequences that we intend to, we probably need to learn more about the connections among the water systems in our landscape and how decisions in water management percolate through, literally and figuratively, the hydrologic system and the ecological system. Okay? A lot of what we don't know as well is how to work the human dimensions into this. Because so much of the plumbing of this system, of the hydrology of this system, of the ecological resources that we have in this valley are directly related to human activity. And so it is my judgment, maybe my natural science colleagues can abuse me of this belief, but it is my judgment that our natural science is a lot better working in systems and landscapes that don't have a lot of people messing with everything than it is working on systems and landscapes where it's really complicated to do research because there's so many interventions in humans. But I think to answer this puzzle, we need to deal with that. We need to understand the science of integrated human and natural systems. And this is going on around the country. People are having this conversation. So we're part of actually a really interesting movement in science to figure out that very question. We also had two specific objectives. Can you guys see these well enough? Do we need to turn the lights at all? Okay. We said we would, all team members would work to understand each other's science, the component scientific models. We have a lot of pieces of this puzzle already pretty well figured out, or at least far along. And one of the things we've got to do is understand one another's work so we see opportunities to put things together. Okay? The agricultural irrigation world doesn't always talk to the hydrologic landscape modeling world. I don't know why. But they model systems, and those systems are clearly related and nested. The people who do a lot of the ecological research or fisheries research don't always work intimately or closely with the folks who are doing those other things. And so bringing these component systems together so that ultimately we will work towards what we call an integrated system. We'd also like to particularly focus on how we bring human dimensions into our models. So what do you do with irrigation diversions and canals and return flows and tile drainage and residential wells and septic tanks and urban stormwater management? Well, how do we bring all that into the models we have of how our landscape is supposed to function? How do we understand the constraints that decision makers face, who are the actors that kind of shape the character of that human part of the program? As a social scientist, that's where I live. I mean, how do we understand the kind of motivations people have and the constraints that they face in making their decisions as we try to project out the implications of how these systems work? And finally, we stated as an objective, and I'll return to this several times today, that we really want to understand the science in a way that we get stakeholder or non-science input so that we are sure to have a pretty good chance at the end of this to do science that answers questions that real-world water decision makers want answered, not just the questions that the scientists think are interesting, if you see what I mean. And the only way to do that is to work hand in hand as you develop science and as you develop the kinds of projects that we're talking about developing. Let me just back up then. The kinds of water management decisions that I'm at least throwing out at the start of this process as being interesting to us, as things that we got to understand the implications of, include efforts to increase the efficiency of the water transmission and use, the irrigation systems, the canals, the sprinkler systems, urban water use. Efforts to increase the application of the efficiency of agricultural irrigation, for example, has lots of consequences for other systems that we often don't appreciate. And it's increasingly obvious in studies around the West that what seems like a no-brainer, like we just got to use this water more efficiently, produces other kinds of consequences that generate challenges that, had we have anticipated them, could have been managed better with more foresight. And so that's a kind of decision that we're going to try to understand the implications of scientifically. Changing the operation of reservoirs and dam releases. Those changes are motivated from a whole cast of possibilities, including things like managing the different kinds of flow regimes we're going to see if the projections for changes in precipitation patterns associated with climate change come true. We're going to see a lot more rain and a lot less snow, a lot earlier snow melt, a lot more water moving through our systems, and it's already been foretold that we may not have the storage systems to work with the water that's going to be the kind of delivery that we're going to get on water. And so we're going to have to think about that. We're expecting managers of systems at that scale to be making decisions and trying to understand the implications of those decisions throughout the rest of the landscape. I study rural land use change and the transformation of land ownership from agricultural ownership to residential ownership throughout valleys like the Cache Valley has implications for the water use, for water recharge, for all sorts of motivations and behaviors. And I think that's a shift in water management behavior that I'm really interested in keeping some attention on. And then the final one is the kind of the formal allocation and reallocation of water rights, which has been discussed since I was in high school in the 1970s, and yet is still kind of unrolling in the West. And what it means is still yet to be determined, but we know that there are going to be programs and efforts made to reallocate the existing water rights structure to accommodate new demands and from urban users and urban centers. And so those kinds of decisions are going to be made. The structure of those new legal systems is kind of under debate right now, what it looks like. And those decisions have implications for hydrology, for ecology, for humans. And I think I'd like to make sure that these are good examples of things that we understand at the end of this. Questions as I go along? I kind of feel like I'm giving a lecture, and that wasn't my design. So what are we going to do? We have 4 activities that we proposed in the grant, and we've got money to support them. We actually have money for treats, and unfortunately I didn't buy treats today. But there is money going forward in which there'll be food, and now we have more money for all the remaining sessions because I didn't spend any yet. I don't have a P card yet, and we had just got our accounts approved yesterday, so had I spent the money, I probably wouldn't have gotten it back. This workshop, this work group, these weekly meetings are the first kind of major foray that we propose doing, and they dominate my thinking about what we're going to be doing for the next 3-4 months, at least into January. And the goal that we set out, and we're going to now accomplish this maybe in some time that I hopefully leave us, is that we'll do a short presentation and we'll have plenty of opportunity for discussion. And the discussion can go a lot of different ways. The goal is to get to know each other better at these workshops, to understand the work that we already do as individuals in the world that's relevant to these topics. Because I don't know enough about what most of you do, and even those I've worked with for years, there's many aspects of what you do that I don't understand. We'd like to do this with scientists, so I've got lots of you that I'm going to be asking to volunteer to give presentations. 20-minute presentations, maybe we get 2 per session, and we do 40 minutes of presentation time and 40 minutes of discussion time. We want to do this with folks who are outside the university, which might be scientists as well, but who work in agencies and government. We might want to talk to people who are key decision makers and have them come use this forum to talk about the kinds of challenges they face in the work that they do and give us some ideas of the science that they'd like to see. We understand more about their situation, they begin to understand more. And we've asked people certainly water management, folks are interested in water management, to tell us about the issues and concerns that they have as they move forward to this future world of water scarcity and water demand. 3 other things we're going to do. I don't want to talk as much about them today because I'd like to focus in on what we're going to do the rest of this fall. But just looking down the road, we propose doing some more in-depth retreats that focus on science methodology that will really be designed to write an integrated method section for research proposals. And that's not only going to involve scientists who are from the same subdisciplines, but the whole team will get involved in all of those retreats, and we'll have stakeholders at all those retreats to kind of keep us accountable and learn as we go into that in-depth moment. I expect that'll probably happen towards the end of January. But we'll kind of see how we go, and when we're ready, we've got money to reserve some place and go and spend time doing these intensive retreats. We have money to bring speakers from other places, and I've already begun to network with some people working on other NSF-funded projects like ours from our region. There's a team up in Idaho and Washington State that got a grant just like ours and is working on those same issues in the Coeur d'Alene, Spokane area, looking at water scarcity and urban transition. So those will be opportunities that we'll kind of bring out as we go along. We want to do field trips and get out of the university, and my vision is immerse ourselves in a couple of communities that are places where water and water management is really critical, and learn in that conversation about the perspectives and the concerns and the sensitivities of actual water, the water use community, the water management community. One possibility is to go into the Little Bear, where a number of us have worked on a number of projects for a long time. And so we've got some things we can bring to the table, what we know about the Little Bear system, but also we've got contacts to develop speakers and people to possibly show up at a meeting. We've also talked about our footprint being bigger in the whole kind of lower Bear Basin, maybe downstream from the Utah border. Maybe we go wherever we want to go, but broadening the footprint and going into some other places that might be very different or complement the Little Bear. And then finally, we promised the NSF we're going to write a synthesis paper about how you do this kind of science, and try to. That can just be its own value. We get something out there that defines the product of our labors in what we learned and what we recommend doing going forward in doing integrated water science. We talked about a published paper, and I think that would be a good thing to do. It can be a lot of things. It can be a published paper and a white paper science plan. It can be a draft of a method section for a proposal or a set of proposals. It can be a lot of things. But I do think we ought to, at the end, try to synthesize what we've learned and produce, something or things that are tangible. Because there's no guarantee that NSF is going to dump another pile of money on our heads, or anyone will. And we'd like to get value out of this that sustains itself within our community, maybe similar teams that are like us. So that last product, I haven't thought that much about. We haven't talked that much about since we wrote the grant. But let's keep it in our mind's eye that we do actually at the end want to write some stuff down, as fun as the meetings will be. All right, so let me give a little bit more background, then I'm opening it up to you guys. When I was at this meeting up in Idaho, it was about transdisciplinary or cross-disciplinary communication and research. And this is one of the slides I stole from one of our speakers. My picture is better than your picture. I don't know what it looks like from the front. But, there's a lot of books that have just come out on tackling wicked problems, creating interdisciplinary, transdisciplinary research. One thing I quickly learned is that there's lots of different definitions of how these terms are used. It's not a settled area, but there's a very vibrant and growing community of scholarship, anyway, in science that thinks this is where the action is in the future. So that a lot of innovation, a lot of creativity is going to come from building teams of people capable of crossing disciplinary boundaries to solve problems and address issues. Arizona State University, do you guys know the Arizona State story? I got an earful from the president of Arizona State at this conference. And he stayed the whole weekend. How many presidents go to meetings and stay in their short sleeves for sessions with 30 people and engage the conversation? This guy takes this stuff really seriously. He's the president of a 70,000 student university. That's how many students they have in Phoenix right now at Arizona State on campus. And he is, by fiat, and probably with more of a dark side than he was sharing, reorganizing the university to get rid of departments and disciplines, and everyone is organized into schools that have sort of issues or problems as their theme. And then you flow to the school that you want to work on, and you work in a department context that has people from all sorts of disciplines working on that problem. And students get degrees in the problem. I mean, he believes they will get jobs. And apparently they are getting jobs. They are this is pretty exciting to the people that are working there. Now, the faculty hated it, of course. The first 2 years were very unpleasant. But apparently it has turned the corner, and people really, he says there's 10% of the faculty that still hate it, and they'll probably all be gone soon because it isn't a fun place for them to work. But the 90% of the faculty and the students and the staff are on board now with doing something that's kind of cool and special, and money is just piling on because the federal agencies thinks this is the cat's pajama. This is the future of how we fund medical research or how we fund environmental research or how we fund work on, you form these collaborative groups of scientists with heavy stakeholder involvement, and you go about trying to use the university to solve those problems. And so they're solving Arizona's problems right now down in Phoenix, he says. Well, interdisciplinary research or transdisciplinary research are words that mean moving in that direction, towards that kind of model. And I'm not waiting for Utah State University to get a president who wants to say, we're going to blow up all the departments and colleges and reorganize this from scratch. Because odds are the person who does that might do it in a way that none of us like, and 90% of us will be unhappy, and 10% will like it. Whatever they did in Arizona seemed to work, but that model is not a model I jump into readily. But I do think this team is to me, more than just a group that could get another grant, but an opportunity for me to develop collaborations and partnerships to kind of build towards doing that kind of science the rest of my career. And so that's why I'm here. That's why I'm invested in what we've done in recent years with some of you and what I want to do into the future. And I'm going to be buying some of these books using our money and making them available to people other than me if you guys are interested. So there's a variety of references that I'd like to build a little library on that this team can use and people can have access to. I've already asked for advice on hydrology for beginners, and I've got a great reading list now because I hang around hydrologists enough that I kind of learned the words that they use, and I can pretend and sound like I know what I'm saying, but one day I will be unmasked. And so I've decided I need to really read the hydrology, and so I carry around a boring hydrology textbook in my briefcase, and I've been reading it in my free time. And you may get a chance to suggest readings in your areas that might be good, accessible readings for people to learn, again, about what each other does. Without having to be that person, you can learn enough to be able to interact and understand what their work is. So as you think about interdisciplinary or transdisciplinary research, I don't care about the distinction between those terms today. There are at least several stages or two ways that people talk about it. The obvious one is it's blending the disciplines. And blending the disciplines happens in my career usually in what I would call multidisciplinary research. And in the world of these people, multidisciplinary research is what I refer to in some stuff I've written recently as parallel play. When I had toddlers, and toddlers, the way they play with one another is they all use the same space and they coordinate their activities loosely, but they all pretty much work autonomously, and they don't share their toys very well. And scientists do this too. They get large science projects with 4 different projects that have 4 different sort of disciplinary, one for each major discipline that's represented. And I'm usually the social scientist that does the token social science piece that's at the end. And you're expected to go do your thing, loosely collaborating at all with your colleagues. And this is what most large science or multidisciplinary science looks like. It's it's good. It can be a lot of fun. I make fun of it, but it is what I mostly get to do, and it's not a bad thing to do. I like my social science. I kind of like to be left alone sometimes just to do what I do well and trust that you're doing your job well. Okay. When you step from multidisciplinary into something else, you're beginning to do the work of other people or blur the boundaries of the disciplines. And you start talking about it as interdisciplinary usually, meaning that I will be involved in your part of the project too, and you should be involved in my part of the project. And we're going to be interacting a lot more than multidisciplinary models suggest. When you get the transdisciplinary people usually are saying, I don't even have disciplines anymore. We're just going to do what needs to be done to answer the question. And we all bring to the table certain depth and expertise, but transdisciplinary scientists often have expertise in more than one discipline and are able to build a skill set that allows them to see how to do science that's not just in their one depth area. Okay, that's one dimension of interdisciplinary discussions that I'd like to have. The other dimension that's not obvious to people is it also usually involves bringing people to the science that aren't usually in the science box. Stakeholders is a way to refer to it. It's not a very good word. But stakeholders can be brought in a lot of different ways. Multidisciplinary projects typically bring stakeholders in as an audience that we need to change. So we got to understand them and get them in the project so that we can, once we figure out what to tell them and what they need to do, we know which ones to tell and what to tell them to do, right? And this is pretty much a classic way that we interact with stakeholders, is we know the answer. We've diagnosed the problem. We've thought a lot about it. We know what you should be doing. And this is often when the social scientist is the front person who has to go tell those people what it is that they're doing wrong and how it's causing problems, and this is how they should fix it, right? And it doesn't go so well because people don't always believe you. So you could think of stakeholders as just your audience. You can also think of stakeholders as informants that actually know something that you need to know, but you go out on these little forays into the world and you collect what they know about the world, and you come back and you keep doing your science. But that's important kind of additional information. Well, the deep version is the stakeholders do the science too. The stakeholders are a part of the science team. And in the literature, this is kind of one of the ways people use the word transdisciplinary as opposed to interdisciplinary. It's not always used this way. But it's a signal to the scientist that we're going to bring science and society, if you will, together. And that's hard to do. It's a different model for how we do science. You give up some of the prestige and isolation that scientists often cherish to bring people in who are not trained necessarily in the same way, but that you give stakeholders a role in deciding the research questions, interpreting the results, deciding how where we monitor, how we put things out. They have to get up to speed to play that role, but that's a role you could give stakeholders if we get somewhere where we want to choose to do that. And then this is the final slide, I think. And this is evaluation mechanism that some of the researchers that do studies of interdisciplinary teams use to talk about where's your team at? Where are they on the spectrum of developing from a single disciplinary or multidisciplinary team to a transdisciplinary team? And some of the litmus tests are, when you watch this team function, are people primarily operating from a disciplinary orientation in which there are one or two disciplines that are clearly dominant and everybody else is kind of adding value to that dominant discipline? Are the disciplines really parallel, or are they actually integrated, where it's kind of hard to tell who's which discipline or where the disciplinary boundaries are? With knowledge engagement, do people behave like, I'm the expert in survey research and none of you are allowed to talk about the survey? Or are they beginning to say, let's coordinate our efforts in designing this, or deeply collaborate on the design of science and the expertise claims? And is the orientation of work, individual-oriented, group-oriented, team-oriented, top-down versus, I don't know what web-like servant leadership means. It's the one part of this slide I stole. It's in the book. But the idea being, these are things that we can think about as useful tools if we decide we'd like to walk down this road some ways. Maybe not all the way to the end, but walk from just a multidisciplinary team project to something else. Well, we ought to think about whether we're hitting our marks by watching ourselves in 6 months and whether we're beginning to behave like a team that understands when each other's work and is collaborating and communicating effectively. The key to cross-disciplinary teams, though, in the end is communication. And being a good sociologist, usually communication involves just talking to people. And talking to people usually involves food, but I forgot the food today. Learning about one another's work, learning each other's languages. There's a workshop that I'm going to propose we bring here that was developed in Idaho that allows teams of people from different science disciplines anyway to discover how differently they use the same words, like theory, or what the standards of evidence are, or what a valid scientific design can look like. Recognizing that when you get people from these different parts of the scientific universe, they have been trained in very different ideas of scientific methodology. And unless you put that out front on the table, it's going to eventually blow up in your face and lead to problems for your team. So this exercise that we may pay people to come down here and do with us is a chance for us to share our own philosophy of science in a relatively